All right. This one's big. I will tell you, though, that I'm going to have to show you this same information lots of different ways because you're going to get it shown to you lots of different ways. What you're going to see here is what professors will expect of you when you go on, if you go on. Unfortunately, the AP decides to show it to you about 6 other different ways that you won't necessarily need. But for those of you planning on taking that, I'll show you the other ways too, and it just makes you think a little bit more, so that's okay too. We know that the first derivative tells us what? What information can we gain from that? Slope, rate of change, or is it getting bigger or smaller, right? Because if a slope is positive, do you agree if a slope of a line is positive, it looks more like that, right? And if a slope of a line is negative, it looks more like that, right? And that's kind of what it's saying here. You see decreasing, it has a negative slope right there. Do you agree all of these would have a negative slope, right? And do you agree right here, this is a constant slope or a slope of 0, right? Is that the slope of that line right there? Yeah. And then over here, aren't these all positive? So they would call that increasing. Does it make sense, the words they put to it? Decreasing, it makes sense. Okay. But the thing that I've tried to really emphasize is where can it change from decreasing to increasing or increasing to decreasing? Where can it change? Critical values, critical points. Does it have to? No. And what we're going to test today is we're going to test all those places it can, which you called critical values, and we're going to find out, does it? And if it does, what are we going to get? Extrema. They could be, what are the 2 types of extrema? Absolute or relative, right? And we're not going to be too concerned about the absolute versus relative today, but we are going to be able to find out if it's an extrema or not. Okay, because remember, it can change direction, so we don't know. So the first thing we're going to do is here it says determine the open intervals. It's just open intervals that says don't include the points you're going to use in your interval, on which that function right there is increasing or decreasing. And the only place it can change from increasing to decreasing, critical values. And where do we find those? Where the slope is 0 or undefined. So if I'm looking for where the slope is 0, like that one right there, right? Or the slope is undefined, what should I probably do? Figure out the derivative of this thing. All right, well, let's do that. Derivative of this function. Well, I gave you a relatively nice function to start with. The derivative of this first term, 3x squared, right? No big deal. And the second term really isn't that bad as well. Minus. You take this 2 times the 3 halves, so the 2's cancel, right? So negative 3x to the first, right? So normally people don't write that, but you can if you want to remind yourself that you've done that. So you just told me that I want to find out the places that this original has a slope of 0 or is undefined, right? So we look at the derivative, and we find out where's the derivative 0, or what would make the derivative equal 0, or where is the derivative undefined. How about that derivative? What do you think? Undefined? Do we have to worry? How come we don't have to worry about undefined in this particular derivative? Yeah, you can't divide by 0, right? There's no asymptotes, there's no discontinuity, so we're good. So you don't have to worry about that. But we do have to find out where it equals 0. So let's do that over here. And why are we so concerned about 0? Because don't you agree, this is the slope of that line then, if it is equal to 0? And how would we go about that algebraically then? Yeah, might as well take out a 3x. Now remember, this only works when it equals 0. A lot of people forget that minus 1 when they factor. Of course, you're not going to do that. Because you remembered that when I multiply this back out, that's in green here, I have to get what was in red earlier, right? And if I multiply this out, do I get back to what was in red up above? I actually do. And so now what you can actually do, because it does equal 0, you can set each of these, this is multiplication right there, right? So you can set each one of them equal to 0. So what happens when I set 3x equal to 0? I get 0. I'm sorry it's so low on the smartboard there. And then I can set the other one equal to 0. And what is the result there? X equals 1. So So of this entire graph, the only places that it can change direction, because let's look at that graph. It's x to the third minus 3 halves x squared. That's continuous, right? There's no discontinuities on that thing. It just goes on forever, right? There are two places that it can change direction. It can change direction at x value of 0 or an x value of 1. Do we know right now whether it does or not? No, we don't. We just found the places it could, right? So now what we're going to do is we're going to decide, well, what could happen? And so if you look back here, you agree with me, I hope, that I can put in any x value I want, right? I could put in 10, I could put in 1,000,000. There's no discontinuities on that, right? Every x value has a y value, right? And so we're going to say, here's your intervals that it's talking about. And these are open intervals, so we're going to use parentheses. So it's saying I could go as far negative as I wanted to, right? I could plug in negative 10 million, right? I could plug in negative 1,000,000. I could check any of those values, right? But what it's saying is all the way from negative infinity is what we're going to call it, all the way to 0, I'm going to make a guarantee to you. You can pick any value in that interval you want. I guarantee that that entire graph will be doing the same thing the entire time. It will either be increasing or decreasing the entire time. How can I make that guarantee? Exactly. As you're going left to right, the first time it can actually change direction is 0. So don't you agree that whole time, no matter where I am, it has to either be increasing or decreasing? Do we know which one yet? No, but it has to do the same thing, right? So what's the next interval that it has to be doing the same thing the entire time? It can't change. Yes. Close, you missed one. Yeah. 0 to 1. Right? It can change at 0. And then from 0 to 1, doesn't this graph have to do the exact same thing? It can't change until it gets to 1. And then was the other interval that was said the last interval for this one? Yeah. Yeah, she was ahead, right? She was ahead of us and giving us the other one. From 1 to infinity, this graph has to do the same thing. Increase or decrease the whole time. Do we know if it has changed direction at 0 yet? Do we know if it's changed direction at 1? No. I'm just organizing this for you is all I'm doing. Right? And I've talked to a lot of college professors, and they like this organizing technique. So this is a good one for you to know. Writing the intervals. Here's the best part. There's a lot of x values in this first interval, isn't there? Negative infinity to 0. The greatest thing is every single one of you could pick a different value in that interval, and you will come to the same conclusion. If you do it properly. I should add that little disclaimer. Okay. So what you're going to do is pick some value that's in that interval. So according to the way the interval is written, can I choose 0 based on how it's written? No, right? It's a parenthesis, right? So you can't choose 0. Can I choose negative 1 according to the way it is? Can I choose negative 100? Negative 2 million? Yeah, I can choose anything, right? And what I do, I'm kind of stubborn. I like to choose things that'll make things obvious. And something like that, negative 10, and I normally write down the value I'm going to choose because I get distracted from time to time, and I might forget what number it was I was thinking about. I hope you agree that negative 10 is in that interval. What I'm going to do is I'm going to find the slope at negative 10. If that slope is positive, what has it been doing the whole time? If that slope's positive, it's been, if that slope is negative, it has been decreasing the entire time. And let's say you chose negative 1. Should you get the same positive negative answer? Will it be the same numeral, same number of the slope? No, because the slope can change a little bit. It can increase very fast or very little, but it'll still be the same positive negative. Okay, so let's try negative 10 and see what we get. So if I want to try negative 10 and find a slope, where should I substitute that in? Should I substitute that into the original? If I substitute negative 10 into the original, what will be the result? What will it tell me? It will tell me y. Is that what I want? No. I want slope. I want increasing or decreasing. So where am I going to substitute negative 10? Derivative. Take this time to make a note to yourself where you actually substitute these values into. Write it off to the side, whatever it is you've got to do. You substitute that into the derivative because I want to know, is the slope positive or is it negative? Did I tell you I actually care what the slope is specifically? Nope, just positive or negative. I really don't care what it is specifically. And now you might say, well, why do you choose a number like negative 10? Well, look here, negative 10, and you square that thing, that gets to 100 real fast, right? Times 3 is 300. Minus, what, 30? It's pretty obvious if that's positive or negative, isn't it? Yeah, plus 30. Is that pretty obvious whether it's positive or negative? Yeah, so all you gotta do is write down if it's positive or negative. Did anybody try negative 1 by chance? Let's just do it real quick. Let's say you try negative. Negative 1 squared. 1 times 3 is? Okay, negative 1 here, so it's 3 plus 3 is 6. Is it still positive? Is it a different number? Big time different number. And I'll show you why when we graph this thing. It's a different number, but is it still positive? Yes. What if you chose negative 2 million? Do you believe that will also give me a positive number? Yeah, because it's negative 2 million squared, which is positive, and a negative times a negative, which is positive. You add them together, you get a really big positive. Doesn't matter. But what if I try something else? Am I still guaranteed that it'll be positive if I try, say, 0.5? Am I still guaranteed if I try a positive 0.5 that it will still be positive? No, because at 0 it can do what? Change. So at 0, after 0, could it start decreasing? Yeah, it could.
Put a negative 0.5.
I could put a negative 0.5, but that's not what I said. So let's try this interval. Unfortunately, this is a very small interval. Yeah, 0.5 is your best shot. And what do I want to know? That's the key, and that's the stuff you should probably be taking notes on. And why do I want to know if it's positive or negative? Yeah, is it decreasing on that interval or increasing? Because it has to do the same thing the whole time. It can't change. If you found your critical values right, it can't change. There are rules, right? So you put negative 0.5 into the original? No, you don't put it there. That's if you want y. Put 0.5 in here. Well, that's kind of hard, so let's do that outside. So 3, take 0.5 and square it, minus 3 times 0.5. This is a tricky one for some people. When you square a decimal smaller than 1, does it get bigger or smaller? Yeah, smaller, right? Because this is really 1/2 that I'm squaring, so it actually becomes 1/4, right? So it's 0.25 minus 1.5. So this is saying I got 75 cents and somebody stole $1.50 from me, which is impossible. But we know that it's negative or positive. Negative. Wait a minute. Did it change direction? At 0, it changed direction. So not only is 0 a critical value, it is an extrema because it went from increasing to decreasing. When you see the graph, this will all make sense. Trust me. Those of you that are still a little sketchy. All right? So what am I going to do over here? Now, here's what we're going to do to test this. Every one of you put in whatever value you want to put in. Can you choose one? No. Don't choose one. I can guarantee you what you're going to get if you put 1 into the derivative. What are you going to get? 0. We just solved for that. All right? Put something between 1 and infinity in. I don't care what. I'm going to be really aggressive. Because I can look at it and tell what's going to happen. All right? So you try something other than 1,000 because that's my number I'm trying. So take a second and find the value you want and tell me positive or negative. All right. Now you may wonder, why would I choose a number like 1,000? But that's because, everybody's attention back up here? I can put 1,000 in there and square it, and that gets huge, right? Times 3, minus something nowhere near as big. So I know for a fact right away this thing is positive. So if you chose 1.1, or if you chose 2,000,001, or maybe you chose 3, or 24, or whatever number you chose, did you get positive? Yes. If you didn't, you did your algebra wrong. All right? So find out what happened with your algebra. So we already know 1 is a critical value. Is 1 also an extrema? How do you know? It changed. Are we guaranteed they change? No. If we were, we wouldn't do all this. Now, for your assistance, let's graph this thing and get a visual of what we're looking at. Now, please realize all the information that you just collected is really about what? Is it about the derivative or is it about the original? This is all about the original. This is what happens in the original, not in the derivative. Right? That's a key for some people to figure out. So what do we got here? X to the third minus, and I like to do it this way, 3 halves x squared. All right? That's the problem, right? Okay, I'm going to change my, well, I'll just zoom standard. I'm probably going to zoom in, though. Yep, I'm going to zoom in. Now, right now, it's got a little crosshairs right here at the origin. I can always move that if I want to zoom in somewhere else. But I think that's a pretty good place to zoom in. Oh, yeah, I mean, that's where everything's happening, so might as well go there. So, do you agree x value of 0 is right here? The y value apparently is also 0. And here's x value of 1 right about there, right? So, from here this way is negative infinity to 0. Do you agree that it was increasing the whole time? As I went from negative infinity all the way over to 0, again, from left to right, was this increasing? So did it matter if you chose, say, this point or this point or that point to put it in the derivative? Should it have given you a positive slope? Yes, it doesn't matter. Was there any guarantee that it was going to change at 0 until we checked? No. But look at from 0 to 1. What is it doing the whole time? It's decreasing. So we chose, what, a half? Because it was just easy. If you would have chose a quarter, would it have been negative? Yes. Chose this one, would have been negative. Wouldn't have mattered. At 1, it has to decide, do I want to change or not? It says, sure, let's do it. And so anything this way is positive. Now you realize the further out you go this way, that's pretty steep for a slope, right? So you're going to get a much larger number than the other people if they chose, say, this one. But it's going to be positive. That's all that matters. So based on our information and this graph, do you agree they match? The information matches. So here's what we can be for sure about. Now, a little bit of knowledge about these graphs is very helpful. You got to kind of know what x to the third looks like, right? You know, it keeps going both directions because it's an odd type function, right? So it goes in both directions. So we know there's a relative, well, I'll leave a blank there, at x equals 0. Because at 0, did it change? Yes, it did. And what was it doing? Here's how I look at it. Positive I think of as increasing until it got to 0, and then it started to decrease. So that's a relative what? Max. Right? It goes increasing to decreasing. Relative. Max. Relative, well, that's terrible. Relative what at x equals 1? It's going, this whole time here, it's going down. And then does it actually increase? Yes, it does. So relative, yeah. That's the first derivative test. Now, the first one took a while, but were any one of those steps all that difficult? Not really, right? Because look at down here, this plus, minus, plus. Do I even care? I didn't even write a number. Okay. Now, I went beyond what I had to do for this problem because we were kind of working through this one. I went way beyond what we had to do. But it says determine the open intervals that is increasing or decreasing. Again, we went way too far, but that's right. Negative infinity to 0, would you label that as increasing or decreasing? Increasing. So that's all you have to do is that next to that, right, increasing. From 0 to 1. Yeah, just write decreasing next to it or something. And then 1 to infinity is increasing. So make sure you watch the question. This didn't even ask for extrema, but we were doing such a good job, I just kept going. Okay? Oh, hey, there you go. decreasing to increasing. Wow, what was that? Gives you, well, that's worse. All right, gives you a what? Relative. It very well could be absolute, right? And we would figure that out when we looked at the graph. And when it's increasing to decreasing, max. And everybody's favorite. Let's say, remember we say it can change direction. So let's say it's increasing and all of a sudden says, you know what, I kind of like this increasing thing. I really don't want to go down. Okay, it did anyways. But your increase, no, I'm going to keep going. Did it change direction? No, it went from increasing to increasing. Is that an extrema? No, it's a point of inflection. Or it could say, yeah, this is kind of fun. You know, we're decreasing. Should I go? Yeah, no. Not going to. I like the decreasing. We're just going to do that. Point of inflection. So it's not an extrema. Is it still a critical value? Yes, it is. It's a place it could. Okay? Yes. Nope. Very good. In that split second, it is 0 for that split second. But did it ever go positive? No.
Whoa.
Whoa. No, I don't know what happened there. Did I hit something on my way up, or
Open up.
is it? Well, I'll fix it by then. Anyways, so right here also, for a split second, it is 0. And that's why it showed up as a critical value, because for a split second there, it kind of was. But it said, nope, because this one never did what? It never went negative. Never went decreasing. So nope, done. Great question. Increasing, increasing, decreasing, decreasing. It means something a little bit different on there. It means something a little bit different there, but it's close. All right, here's what we're going to do. I want you to get started on this one because I got to go figure out what's wrong with my computer. Start on this one. Find relative extrema. Now the directions are different. But wait a minute. What was the first thing we did when we started this problem? It just wanted increasing and decreasing. And didn't that help us figure out relative extrema? So do that first. Go find out where can it change direction. And then write the intervals and find out does it. Hopefully by the time you get at least half of that done, I will have figured out what's wrong with my computer. Yes, I think chain rule would be a very good choice. All right, apparently the computer will not do that again now. All right, hopefully. So, student wearing a blue t-shirt. That's sitting towards the back of the room. What should be my first maneuver? So in general, what are you telling me to do? No, just tell me what you're wanting me to do. Okay, take the derivative. And why are we taking the derivative? Figure out slope, but what are we finding first before we look at slope? Where it can change. What are those called? Critical values or critical points. And what rule are we using here so far? Chain rule. But unfortunately, I made a mistake. I didn't take it down to power. Very good. So where does that go? After the x squared minus 4, and what should go there as a power? Negative 1/3. All right. So as you were told before, sometimes it's best to rewrite these. But what were you told about radicals in the denominator? Leave them. Do we have a radical in this denominator? Yeah, we actually do. So let's look at that. I hope you agree that that 2 right there kind of wants to stay in the numerator. And this 2x is also in the numerator. So do you agree that's a 4x? Okay. This 3 right there is in the denominator. And all of this is very much unhappy. And so would very much rather be, well, let's just rewrite it as we're at it. So it's 3 It's a radical, though, because it's a fraction, right? So x squared minus 4, well, to the 1, but yeah. It's just the third root, right? Is really what 1/3 means. Because I took this 2 right there times the 2x that was also going to be in the numerator. So I multiplied. Okay? Now, your job is to find critical values. And as we were told earlier today, that is where the derivative either has a slope of 0, or the original has a slope of 0, which is where the derivative would equal 0, or the derivative happens to be undefined because the slope would be undefined. So you're looking for this one right here, the vertical tangent and the horizontal tangent. These are the two you're looking for. And so what we're going to do is set this thing equal to 0. But here's the nice thing about me telling you to leave those radicals down there. If you're solving this, what's your first move? You take this entire denominator and multiply it up over to there, right? Because if I multiply it by that on the left side, it cancels. So if I multiply it to the right side, it's 0 times all of that, which is 0. So when you set it equal to 0, you basically end up with that. So x equals 0. And what is that then again? What's that called? Critical value, right? So that's an x value where it might change direction. It might not. There are, I believe, 2 more places that would make it undefined. And really, do you notice now, if you have just one fraction like this as our derivative, that's why we worked so hard at getting one fraction. All you have to do is set the top equal to 0 and set the bottom equal to 0. That's why we did all that work with factoring that stuff out and all that, so that you can get to this spot. So just go ahead and set the bottom equal to 0. These will be the places that will cause the derivative to be undefined, or that vertical tangent. If we set that equal to 0, what's probably the first maneuver? Yeah, this 3 right here, let's divide both sides by it. And what happens on the left side when you do that? Cancels. 0 divided by that is 0. It's gone. And so how are we going to take care of the cube root? Yeah, cube. Oh, look at that lovely 0 over there. Oh, so it's just gone. So x squared minus 4 equals, 0 cubed is 0. It's nice that we get to use 0 a lot. And so you could either do difference of 2 squares factoring, that'd be a long version, or you could just add 4 to the other side. X squared equals 4 square root. Yep, positive or negative 2. Are there any questions of how I arrived at 0, positive 2, and negative 2 as critical values? Yes? You don't have to, and I have done that in the past, but I believe that is causing confusion in here. The question was, would you mark positive and negative 2 as undefined? You don't have to. There's still critical values anywhere. Anyways, it's just some people forget to check undefined, which is why I used to have people write it down. But if it's confusing you guys, then let's not do it. All right? Let's just forget about it. Do it a different way. Right? Do we know if 0, positive 2, negative 2 are extrema? Yeah, we got to do your intervals. And again, remember, I told you that the professors that I have discussed this with, can I erase the red stuff here? They kind of like this particular method. And so let's see if we can get the intervals set up here. And I always start with negative infinity. I work left to right because that's how we think, right? And the reason I can do that is basically, are there any x values I can't put in? No, right, I can put anything in I want, right? So I'm going to square it, then take the cube root. So who really cares? I can do whatever I want in the original, right? And so let's start negative infinity. Till when is it going to do the exact same thing? Increasing, I mean not at the same rate, but it will be increasing or decreasing. Yes? Negative 2, very good. A lot of people say 0 on that one. So good job. And again, they're open. Why are they open? Because I don't actually want to be able to use negative 2. And infinity is always open, doesn't matter. Because if you put negative 2 into the derivative, what are you going to get? Undefined this time, but close. Okay, you knew it wasn't going to give you something. Yes? Is that correct? Negative 2 to 0. Yep, they're all critical values. They all count. 0 to 2, very good. See, I told you once you saw that first graph, it would make more sense, right? 2 to infinity. Now, is there any guarantee that these are all extrema? No. In fact, this could be a really strange graph and just kind of do something like this all day, right? And none of them would be, right? It doesn't do that, but some of you already know what it does. But now, here's the fun part. You can pick whatever you want, as long as it's in the interval. All right? Oops, I erased my... And I'll just give you a brief on how I do it. So let's choose something. What do you want to choose? -10? Okay. Here's how I look at it. These are a little harder because it's a fraction, right? So here's how I do it. I say, here's my fraction. Let's figure out what the numerator will be and what the denominator will be, just positive, negative. So let's put -10 into the top. Negative. And I don't even care what it is. I just want to know positive or negative. So negative over, if I put 10 here, -10 and square it, that becomes positive, right? And it's about, well, it's about 100, right? -4 is still positive. Take the third root of a positive, you get a times a positive is, so I have a negative over a positive, which in the end result is negative, right? That's how I do these. And then I just make that negative bigger than those other ones because you get confused. All right? You just have negative, positive, what is that, you know? So we know that this one, if I had to label it, this one's doing what? Decreasing, right? So you just, you know, you can do that if you want. Well, I think there's an obvious choice for the next interval. -1, right? And once again, maybe I'll color code it so it makes more sense up here. So -1 in the numerator results in a negative, right? -1 in the denominator. You take -1 and you square it. It's +1. -4 is a -3. The cube root of a negative is negative times a positive is negative. So negative over negative is positive. All right. So this one is, what can you tell me about -2 right now without going any further? It's an extrema. Do you know absolute or relative? No, but at the very least, it's relative, right? I think it actually ends up being absolute, doesn't it? But because it went from decreasing to increasing, so it's, we know at least it's a relative min, right? At least decreasing, increase. All right. That's another reason I do it left to right. All right. 0. So put in 1. The top is positive. Here's the beauty if you think a little bit. If I put -1 or +1 into this denominator, aren't I going to get the same thing? Because I'm squaring it first. And I'm really not doing anything other than that. I'm going to end up with the same numbers, right? And so we already know the bottom is going to be negative, right? Got to think a little bit sometimes. And so this end result, though, is, oh my gosh. So what can you tell me right now about 0? Extrema. Do we know? And in fact, you can even tell me better. You know, in fact, it's at least relative. And it's increasing to the left of 0 and then decreasing. So it's a relative max. Maybe absolute. We'll find out. Okay. Well, probably not because this was decreasing the whole time. I'm guessing not. But okay. This one here. What do you want to try? Do we want to be symmetric and do 10? Okay. Could you choose something else, though? Yeah. All right, so with 10 in, what's your numerator? Positive over. Well, once again, if you put -10 or +10, you're going to get the same result here. And so it was positive, right? Which is positive. Okay, so what's an extrema? Where? X value of 2. Do I know the y value? No. If you had to find the y value, you would put that value into the original. It would tell you the y value. Okay. I believe, so here we have, so decreasing, increasing on this first interval here, right? So that's a relative min, right? Down, then up, then down, then up. And I put it in the middle so that you can figure out that that's where that would go. See? But I think this looks a little different than that. I believe -4, 6. Ew. That y value is not very nice on your max, is it? I'm just going to not graph that over there for you because I don't want to get exact and find that y value. So this is going to go away. And in general, that's what your graph looks like. Why is it a point? Ah, very good, Cusp. You can tell me this. You've got this figured out way beyond. The question was, why are these two cusps? And this one's not, is it? Yes. No, not a discontinuity, but close. It's not a discontinuity because it's not discontinuous in the original. Yeah. Right. Now here's the key. If we put what the last two people said put together, we've got it. Was it a discontinuity in the derivative? Was it a discontinuity in the derivative? Yes, it was. Was it a discontinuity in the original? No. There's your cusps. So they only happen on certain types of problems, your roots. Okay? What if it was a discontinuity in the original and it's going to stay in the derivative, then it's asymptotes or holes. Okay, they can't just disappear. Okay? We have, no, they're still extrema. Yeah. This right here is a what? Relative. How about these two? Absolutes, right? Now, based on this, would we know for sure? I mean, like I said, we knew it was decreasing this whole time, then increasing, then it came back. But did we know y values for sure? Could this y have been a little more like that, and then that would be your absolute? I mean, we didn't know. Until we graphed it, we really didn't know. I want you to be able to tell me relative. We can always figure out absolute by graphing it, all right? I won't be so mean to assign that one. But for tomorrow, I would like you to do example 4. Now, what's a distinct difference that I'm hoping you notice already? Yeah, there's asymptotes. Asymptotes don't go away. That's going to be a discontinuity in both. It will not go away. You still check, but you need to know that it's going to be an asymptote. Because like I said, it can go from increasing to decreasing at an asymptote. But is it an extrema? Is it still a possible place it can change? Yes. So you still put it in your intervals. Yes. For example, what? Oh, 0 comma whatever it is a relative max. And negative 2 comma 0 and 2 comma 0. I'm just plugging them in here. It's just 0 is not a good y value. Yeah. Nope. We can do better than that. Absolute. Yeah. But if you told me relative based on just the test, I'd be good.